We're going to look at another optimization problem. Okay, so on the same side of a straight river are two towns. So you notice my drawing here. Here I have town 1 and town 2 on the same side, and it's telling me a straight. So I know that this is 4 miles and it's just a linear distance there. And the townspeople want to build a pumping station at point S. So the pumping station is to be at the river's edge with pipes extending straight to the two towns. So where should the pumping station be located to minimize the total length of pipe? Okay, so that means what I'm trying to minimize is the distance here. Okay, and we're actually just going to call that distance D1. Okay, because that'll be the pipe distance to town 1. Oops, some issues with my pen here today. Try this again. So we will call this D1, and this I'm going to call distance 2. Okay, so we're trying to actually minimize, and I'll just go ahead and write this right now. And find the minimum distance, which I'm going to call capital D. Okay, and that'll be D1 plus D2. Okay, so let's go over and look at our steps first for this. Okay, so first we draw a picture, which I already have. We identify the attribute that we want to minimize or maximize. In this case, it's actually a length. Okay, so if I come back over here, you see it's this length D1, and that's actually the sum of two lengths in that length. Okay, we want to write a function for the attribute you're optimizing, and it says you may have more than one variable in your function. So let's look at what my function is going to be. Okay, so this distance, if you notice, is actually the hypotenuse of a right triangle I have right here. Okay, so since it's a right triangle, because we're assuming this distance is measured perpendicular to the river, okay, I know that distance, I know this distance, and x is just my distance from town 1 over to the pumping station. Okay, so it means I'm going to have a variable here that's going to be in terms of an expression for D1 that'll be in terms of x, which looks like it'll be okay. Now, if you remember, I said you should try not to use x as one of your variables, just so when you go over to your calculator you get confused with the x that's actually in your calculator. I'm actually going to call this distance A, okay, just so I don't get confused later if I have several variables and my x ends up having to be on my calculator different than that x. Okay, so now let's look at what D1 is going to be. So D1 will equal, my pen's jumping around a lot today. Okay, so that'll be the 1 squared, which is the length of the one side of that triangle, plus the other side of the triangle, which we named be A. So plus A squared. Okay, and that's actually D1 squared, though, right? Okay, so let's look at what D2 will be. And I can use that same thing, but it's actually going to be D2 squared. That's going to equal, okay, and we can do the same idea. I'm just going to use the Pythagorean theorem again, okay, because it's the diagonal of this larger right triangle. Okay, so D2 squared is going to be 4 squared plus, well, now I got to figure out what this length here is going to be. So remember, the entire distance is 4 miles. This piece is A, so this is the part that's left over of the 4 miles after I've already moved a distance of A. So we're just going to call this 4 minus A. Okay, so this will be the 4 squared, that 4 squared is this length here squared, plus, right, and then it'll be 4 minus A. Okay, so since I know what D1 squared is and D2 squared is, I can actually write the equation of the distance of both of them added together. Okay, except we're going to have to use square roots. Okay, so it'll be the square root of 1 squared, which you don't actually have to have the square on it, but plus A squared. Okay, plus the square root of 4 squared, or you can make that a 16, it doesn't matter, plus 4 minus A squared. Now don't try to simplify any of this, right? You can't take the square root of the sum of two things and tell me that is just 1 plus a. Right? Remember, algebra doesn't work that way, so we're just going to leave them exactly like they are. Okay, so I did the next step in my here. We wrote a function that we're trying to optimize. You notice I only have one variable in the function. I've already labeled the picture with the variables that I used. Okay, identify the constraint. It says this is usually the number that's given in the question. Okay, and if you notice, I actually, since I only have one variable here, and the numbers given I've actually already used for my minimum. So in this case, I actually don't even have a constraint. All I have is my function that I'm trying to minimize. Okay, and this works out okay. So here's my function, because the main purpose of the constraint is to make it so you can only have one variable in your function. And in this case, I only have one variable to start with. So this is a case where you actually don't even have a constraint. The constraint actually is here, this 4 miles, and this has to be 1 mile, and that has to be 4 miles. So in a way, I've already used the constraint within my function that I'm trying to minimize. Okay, so it means I can skip some of the next parts. So it says write an equation that relates the number in step 5 and labels in the picture. Okay, we don't have to worry about that because that has to do with the constraint. This one also has to do with the constraint, so I don't have to worry about it, or I don't have to worry about substituting. So I'm actually now down to step 9, where it says find where the derivative of the function is 0. Okay, so now I'm going to switch over to my calculator, except I wrote my function, I wrote my function where my calculator screen is going to be. So let me move it down to here. Okay, so if I flip over to my calculator, hold on, I got to find it. Okay, it's right there. Oops. Okay, let me clear my screen. Okay, so I'm going to go to my calculator. I'm going to go to the y equals menu. I need to type this into my calculator. So I'm going to do second square root and then 1 plus, and that's just going to be my x squared. On your 84, make sure you press the right arrow button to get out from underneath your square root, and then plus 4 squared. Oh, I forgot the square root sign. Sorry. Delete this. So second insert a square root. So now I got a square there that doesn't belong. Okay. 4 minus x squared. Except I less right zero. So I got the 4 squared. Sorry. Let me start over. Delete everything that's in there. So 4 squared plus parentheses 4 minus x squared. 4 minus x. I'm having a terrible time today. Okay, x. Make sure you get the square on the outside. Okay. Okay, so there's the second part of my expression. Double check that I actually have it typed in correctly. Okay. And I'm just going to hit the back arrow button just so you can make sure you have the first part typed in correctly also. Okay. First part was a little easier to type in. Okay, so it should refresh here in a second. So there's the first part. Okay. And now I'm going to go in y2. We're going to tell it to take the derivative of y1. Okay, so remember I'm going to go to the math menu, and then number 8, which is take the derivative. Okay, so the derivative here will be x. The variable is x. So put an x in that first box. The function that we're doing is y1. So I'm going to press the second button, and then the trace, which is where the F4 is. And then tell it to use y1. Okay, and then I want to do it over every x that it sticks in, because remember we're going to go over to our solver where it sticks different values of x in to try to find the answer. Okay. Okay, if you're on the 83, I think I can so if I just switch this here over for a second so it looks like my 83, okay, your function should look like this. It'll flip over in a second. Okay, so it'll be the square root. Don't forget to print the into parentheses here at the end of this square root. It'll put the beginning one on for you. Okay, and then again, make sure you put the end one here at the end of that square root. If you forget this one, it actually doesn't matter. But and then your derivative line, the function you're taking the derivative of, the variable that's in the function, and then the value of that variable. Okay, remember the value is just whatever x is that the calculator is putting in. Okay, remember to get to the Y1 button. Just as a reminder, or put that back in for you so you remember. Okay, you're going to hit the VARS button. Okay, which is next to the clear right below the arrow. Scoot over to YVARS. Okay, and you want to do a function. And in my case, I'm going to then choose Y1. Okay, so when we go to the solver, it's going to be the same for both. Okay, so hit the math, hit second quit, hit the math button, and we're going to choose the solver that's at the bottom of the math menu. Okay. And in the math menu, I'm looking for when the derivative is equal to 0. So I need to press the up arrow button, clear that equation that's in there. Okay. Remember, I typed the derivative in Y2. Okay. So I'm going to hit the alpha F4 and grab Y2. That's if you're on your 84. Okay. If you're on the 83, let me get out of there. Oops. Okay, then you can go through the VARS menu just like we did before. Okay, over to YVARS, choose function, okay, and Y1. I'm sorry, Y2. Now I pressed the wrong button, so let me do it the faster way this time. Okay, and Y2. Okay, so now we need to put a guess in for X. Okay. So we know X has to be larger than 4 because if you put the pumping station here and the two towns were directly on the river, you'd have to run 4 miles of pipe. So for a guess, you know it's going to be more than 4, so I might even guess maybe, because we know this distance alone is even more than 4 and this is more than 1, so already we're up to at least 5. Okay, so I might guess maybe 6 or 7. Okay, and then press alpha solve. Okay, and I get 0.8. Oh, I'm sorry, I was guessing what the total length was going to be, not the distance x. Sorry about that. Okay, so actually the answer does have to be less than 4 because it's halfway apart when I was doing my guess. Okay, so I get 0.8. So in this case my a is 8. So I have a equals, I'm sorry, 0.8. And that would be in miles. Okay, so reread the question and actually see what they actually need, because sometimes they actually might want the distance, like how much pipe do they actually need, in which case we'd take the 0.8 and plug it back into this function. Okay, in this case it's not asking that, I believe. It just says where should the pumping station be located to minimize the total length of pipe. So all I need to say is I'm going to locate it 0.8 miles from where town 1 is. Okay, that's not the diagonal distance. That's this distance here, the horizontal distance, right, for where town 1 is.